and I'm here once again to talk about embedded software. Today I want to consider a pretty hot topic in the world of embedded software, and that is multi-core systems. Now, a multi-core system is a device with, multiple cores. But what do we actually mean by that? By cores, we typically are referring to processors of some kind. So they might be conventional CPUs, they might be DSPs, digital signal processors, there could be specialized processors of some kind. But either way, we have more than one. That's what a multi-core system is. Now, one of the problems with multi-core, apart from its obvious complexity, is the terminology. There is lots of ways of describing how systems are built, and this can be confusing, particularly if you're new to the field. So what I thought I'd do today is introduce some of the basic terminology of multi-core, and then maybe revisit on a future occasion to look at some of the more advanced aspects. So, multi-core systems, they broadly come in two flavors, I suppose, at the highest level. We can have a device which is described as homogeneous multi-core. This is a device that has multiple cores, multiple processors, which are all identical. So lots of processors exactly the same. This is the kind of chip you'll find in your desktop or laptop computer, but they're also used in embedded systems applications. And broadly speaking, you have lots of processors just to get more computing power. So that's one architecture. The alternative, as you might guess, is heterogeneous multi-core. Heterogeneous simply means that all the cores are not the same. They may all be completely different, they may be a bit different, they may be very different. There may also be a combination of cores where some of them are identical, but the rest of them are different. So in other words, you can have an island of homogeneity in a heterogeneous multi-core system. How many cores you have in a multi-core device will vary from 2 to many dozens. So there are lots of possibilities with that kind of number to play with. So that's the hardware architecture. We're interested in software, embedded software. There are two ways, broadly speaking, of configuring embedded software on a multi-core device. The first one is called symmetric multiprocessing, SMP. The idea here is you simply have multiple cores and you run a special version of an operating system on top of those cores, an SMP version of an operating system, and it runs across all of those cores and distributes the work between them. As I emphasise, it must be a special version of the operating system to do that, and there are SMP versions of several real-time operating systems, including our own Nucleus product, and there are SMP versions of Linux. Incidentally, on your desktop computer, this is exactly how it works. You can probably guess, if it's not too obvious, that all the cores must be identical, otherwise the code couldn't run across all of them. So this must be homogeneous multi-core architecture to run an SMP operating system. The alternative is asymmetric multiprocessing, AMP. This is rather more common in embedded applications, much more common I would say actually. And here we have a multi-core processor of any architecture, and we run a different operating system on each one, or a separate operating system on each one. They may be identical operating systems, they may be different. In the example I show here, we have Linux running on one core, we have Nucleus RTOS running on another, we may have other operating systems running on other cores. Any combination that suits you. You can choose the best operating system for the application in hand. You may have no operating system actually, you may run the core bare metal as we call it. That's the choice you have. There are many other aspects of the configuration of software on a multi-core system which we can look at on a future occasion. The only one I'll touch on for the moment is, of course, you could have several identical cores running an SMP operating system within a heterogeneous multi-core, which is ultimately an AMP system. Does that make sense? We'll revisit it another day. Just to emphasize, if you want to build a system using asymmetric multiprocessing, so multiple operating systems, you can do that on any multi-core device, whether it's heterogeneous or homogeneous. But SMP is only an option across identical cores. So that's a very brief introduction to what multicore is all about, what multicore embedded software is all about. As I say, I'll return another day to look in more detail, particularly how we build AMP systems. But that's it for now. So, bye for now.